Hey guys, welcome to today. Today I'm going to go through how you put in some floor trusses and then go through some timber framing layouts. So let's come to our level 2. Obviously we've used conventional rafters for our other roofs. So now we're going to use some floor trusses to span through here. That's why we've allowed that 400mm gap. It's a bit messy, but we've allowed this 400mm gap in the architectural to allow for the trusses to come through. So let's put these in. Well, as always, doing structural stuff in the structural tab, and what we're going to do is going to go for a truss. So structural trusses. Trusses we put in a bit differently. There's different ways we can do it, but just note to start off with, we get this Howie flat truss. If we want more of them, we load family, we come down to structural trusses. We've got different types of trusses in here, so you can see the sections of them as I flick through. Obviously different trusses for different purposes, for our roofs or for our floors. So we can stick to the Howie flat truss for now. So first thing for me that I usually do is I'm going to place it on level 2. I can move it after, so level 2 is okay. And let's start by picking a line. So let's just pick this first line for now. This one here. Alright, if I change my detail levels, this is the truss that I've now put through. And we're going to space these at 1200. So what I can do is select it, copy, multiple, click somewhere over here and just start moving the entire way down. 1200. And just note that now what you can see is the reference for the next copy is from the new truss that's been put here. Alright. So instead of going 2400, it's still 1200. Revit is shifting the next datum point from that second truss. Alright, so you can do it this way, you can make an array, you can do it however you like. For me, this is just going to be easy. Beautiful, and how nice is that? They seem to line up pretty well. Good design. Delete that one. This is what's happening with the trusses. They're sitting a bit far out of the walls. Alright, so we're going to have to bring them back in. So how am I going to do that? Well, if I go to modify, I can click this trim and extend. I can go to the internal line, I then click the truss. And do it again for this one and keep going. Or if I go multiple, I can select this line, and now I can just select all the trusses that are touching it, and that will jump back in. Cancel twice. Do the same for this side. So this line, and looks like all of the trusses are touching it. And jumps them all back in. Alright, don't worry too much about this eye section. I will tell you what's going on here in a minute. Alright, the other way you can do it is you can quite simply drag these in. And we can drag this one in again. Alright, and then I might just trim these to here. And that's better. Alright, so that's how we put in trusses. Alright, so it's not anything strenuous, it's not too difficult. You'll go through more of this in structural drafting. So we're just going to learn how to put them in. We're not going to worry too much about all the nitty-gritty details of it. Let's have a look at my 3D and let's see what's happened. So spin around. Alright, I can't really see them sitting outside of the walls, which is good. But what I can see is the trusses, firstly, are made out of steel, which is not going to happen ever, especially for a house. Sorry, it will happen for big structures, and they're massive. All right, they're not fitting in that 400mm gap. So, what you can see, by the way, if you walk around through Tonsley, have a look at the roof. You'll see we've got steel trusses all through the Tonsley campus. So we've got to fix these up somehow. Well, let's take a section through, let's go through here. And let's bring in our section line just to see one truss. Right click, go to view. Move this up, let's have a look. So, massive, alright. Click on one of the trusses, SA, select them all. Now let's see what's going on. Well, I didn't specify the truss height, alright, so I have to change this. So this here should be 400. That's what we've allowed. Apply. Alright, now it's all very squished and it's still made out of steel, which is not good. Alright, I'm just going to tidy up these levels. So VV. I'm just going to turn off the levels from the structural file, which is annotation categories. Find my levels. I'm just going to turn these off. Alright, I set all the levels in the architectural, which is not going to work for me, Nathan. Okay, let's try undo that. Okay, fine. Let's turn off the ones in the link. Alright, that's better. So level 2 should be 3100. Let's make another level above level 1 in the structural folder now, just so we can visualize where things are going. Right click, create similar. Let's put one here. 2700. Alright, let's tidy it up. Let's find that break line. Sorry guys, I probably should have done this before, but that's alright. Cool. This here is the truss bottom, or ceiling level from the architectural. This here is going to be my finished floor level 2, the upper floor. Right. So let's grab this truss, grab them all, SA. Now I can't change the work plane here, but what I will do is I'll move them down after. Alright, so you can do it before, you can do it after, shouldn't be a problem. But what is a problem is the fact that these are still steel. Alright, so select the truss, select them all, edit type, and what I get is the parameters of the trusses. So what you can see is my top chord is a steel beam, my webs are a steel beam, my diagonal webs are a steel beam, my bottom chord is steel beam, which is not going to be used for a house. Alright, we're going to use timber. Try find timber, I haven't got any in here, so I have to load them in. So I won't be able to load them from a section. Let's come back to 3D, structure, beam, load family. Let's find our timber. So structural framing, wood, timber. What we're going to use is we're going to use just 90 by 45 MGP10 studs, I guess, for our trusses. You'll learn more about this in your structural drafting and analysis, and we'll go through in a minute. We'll go through our timber framing layout, and so you can have a look there. So just note as well, you can now see the trusses have all come down, but they're still made out of steel. So load in this timber, edit type, duplicate, 90 by 45, MGP 10, same as our stud walls. So my width, depth, cool. Now let's come back to our trusses. You can grab it from 3D or in the section. select them all, edit type, and now in here, let's grab our timber. Cool. So it does that. The other cool thing about the trusses is you can specify the tie constraints. So I can specify how it starts, I can specify how it is at the end, and I can change the angles. Alright, and then what you can see here is the analytical vertical projection. We can shift this around, and basically what we can do is we can get Revit to analyze some part of the truss. But for now, we don't have to worry about it. So let's just leave it all to be as these are. So we're just changing the timber from the steel. Apply. And then go OK. And this looks a bit better. Alright. Still need to move them down. So select one, select them all, move. Click on the bottom of the truss. What you can see is I can't move it down. So what I need to do is disjoint it, and now I can move it straight down into here. Alright, and this is how it's going to sit. Now what we can do is you should also note that 400, and then it's allowing a stud on top of it. In structural drafting we'll come through and tidy it up more, but this is in relation to the thickness of the top chord. So what we should do is make the truss slightly smaller by the thickness, so it will fit in, which you can do. So if you measure that, we can measure from here to here, it's 45. So select them all, change the thickness to 355. Alright, and then like obviously now it's going to fit in that gap. It's not the best way to do it, but it is one way to do it. And then back from your floor level where our trusses are sitting, we can bring them all into that second line. I'll do it for one that we're actually looking at. Come back to my section, and we can marry them up. Alright, so just be aware that that's how it will sit. Not that far, it comes back to the other line. Nathan, what are you doing? To the inside line. So all the way it sits on the studs. And I reckon I just grabbed the wrong one. Oh, maybe not. How's that? Okay. Alright, so all the way it's going to sit here. We can shift this vertical web across as well. To do that, we edit the family of the truss, but you'll definitely go through that with me in structural drafting, how we edit these families. Alright, so for now, this is okay. For basic drafting, we're not going to go through how we change all these families in here. Obviously we've got many of them, but just be aware that you can come through and actually edit what is in these trusses here. Okay, so that's how we put in, or the basic way that we put in trusses. Just have a look that on this side here we have some issues. Okay, so what you can see is this is floating in the middle of nowhere. It's not supported on an external wall. The reason for that is what we can see is under this section we have no external walls. Alright, external wall sitting out here for the garage and then for the back room. So the second story has to be supported somehow. Alright, so one side of it is okay, the other side of it is not. So you can imagine the type of beams and columns we're going to have to put into here. and we're going to see that in the timber framing layout. So just remember, keep this picture in your mind that there's nothing under here, and I'll explain that now. So this is what happens, or this is what we get for our timber framing plans. So what we do is we send off our architectural drawings to a timber supplier. They charge us between 400 to 800 bucks to do these plans. They put it through their software. There's different companies that will do it. I think Prada is probably a really good one to go to, and they got their own little team that does it. And what it does is they put back in the plans that we give them into their software, and then they start overlaying the timber. So they punch out what our walls look like, our wall frames, our trusses, and everything else. And you'll go through this quite extensively in your structural analysis course. Just want to give you a heads up. So it's not the first time you see it, it is next year. So you're going to have a quick look at it now. So what we can see here is this one here is our upper roof framing layout. So these numbers here refer to the truss types that are sitting across. Thank you. And then obviously any of our little soldiers or ceiling joists sitting through here. So this here is the upper roof framing layout. So our trusses are spanning across, allowing for our eave overhang. Alright, we've got different truss types sitting through here. This is our walls for our upper floor. Quite important, so we'll just quickly go over it. Like I said, you will go over it in real thorough detail in analysis, but we just go through the basics of it now. So MMD, CBD, what else have we got? We've got let's zoom into it, Nathan, be the easiest way to do it. Well, that really worked. MMD, so it's the same kind of bracing board. So what we can see is MMD, MMB, and CBD refer to the bracing types up here. Now you've done bracing in your construction practice, I believe, with Barry, so you should know the differences. Alright, what you usually see is you'll see the hardboard on the corners of buildings usually, and that's because of the wind pressure. Usually the wind is about 3 times as strong on the corners, so we have to brace it. CBD are our bracing straps. Alright, so CBD, this is what we get. This is our amount of wind force or bracing that we can hold with these straps. Alright, or per meter of it. So it tells you all the fasteners, so it tells you what's happening. Usually for bracing boards, they put the board in, then they nail all around it at very close centers. So we're talking between 50 to 150 centers depending, and that's what we can see. So if I zoom in up here, we can see the details of it. Alright, so we can see our fastener spacing, so 80 mil across in horizontal and 150 up top. So they put heaps of nails through it. Alright, these are fixed and they're not going anywhere. So you guys should remember that from your from your construction practice course. You guys did design, I think you designed the straps and the bracing with Barry. Other things that you can see is the walls. So top plate, our studs, our bottom plate details all here. Comes through, just tells you little spacings and all kinds of other details. For us, not overly important for now. Our most important layer is coming up next. Next you can see is obviously W1, W2, W3, 4, 5 to 11. Same with these Ds. These are referring to the doors and windows, which are all seen here. Alright, it's a list of openings. Alright, obviously we're cutting a hole through the wall, or we're allowing the hole to be there. So it's an opening. Next thing you can see is E1 to E15, and then I1 to I36. So E is referring to external wall panels, and I is the internal wall panels. Alright, and that's just all this has here. So this here refers, I haven't attached the drawings here. You'll see that in analysis. This refers to the actual panels, like the framing panels that they have they show the details in an attached appendix. You've also got a little thing here with the bracing capacity in both directions, which is very dependent on the wind classification of where the building is located. So wind class is shown up here, so we've got N1 and our ceiling height is 2700. And you'll learn more about wind and things like that when you are in your structural analysis course. The other thing I missed is in the roof framing layout, is it shows us the roof type and the roof pitch up here too, as well as the spacing of our ceiling joists and our trusses. So like I said before, 1200 spacing for trusses is very common. Okay, so the next drawing, and probably the most important one for us, is this one here. Alright, so this is the ground floor layout. And so let's just have a quick look. So what we can see is we've got 13 FT10, so floor truss type 10, floor truss type 1, and it's spaced the whole way through. Our wet areas typically have different spacings. For the trusses, not so much, but for our bottom floor walls, you'll see that the studs are usually at 600 centers in the wet areas. So, what else is important here? Sorry, as well as obviously the trusses sit on top of the studs, so generally the trusses get spaced a bit closer across the wet areas. But you know, it can change from job to job. The main important thing that we see here is what we look for is B1, B2, B3, B4, B6, beam 7. This refers to the beams. Alright, so the beams that we look for, so if I have a look over here, I have the list of beams. I can see beam 2 is an LVL, laminated veneer lumber, high span 400 by 45, so just timber beams. The main thing that we worry about are these here, these beam by engineer. If we see them, that means that we actually have to do some work, and we've got to do a bit of design around it. So remember, in our section, we've got this wall sitting here with nothing below it. It has to be supported somehow. So in our timber framing layout, that's this beam here, beam 4 and beam 6. So these beams, alright, that wall can be seen to be this wall line here. So you have to design a steel beam to sit to support all of this. Alright, that's how we read that. Then you go through by first principles, software, or by your one steel tables, and then you start designing the steel. Tells us what's happening, cantilever beams, a cough ceiling, so a couple other details that you go through in analysis. But just again, so it's not the first time you see it next year or the year after. We're just kind of a quick overview of it now. And then we've got some other beams at the front here, obviously for the balcony. Come down here, this is our lower roof layout. So obviously the inside is all covered by the trusses that are in here. So this area is here. So we have the trusses spanning across. Another important note is trusses always span in the short direction. Alright, so we're not going to span them this way, they always span in the shorter direction. And what you can see is obviously beam 1 is designed by us. It's quite a long span with quite a lot of trusses on it and quite a lot of weight coming to that beam. Another important fact is designing a house, especially designing steel in a house, is we've got to find out how we can hide it. So it is important that you can model in 3D, and you have to work out how you're going to hide your columns. Obviously the columns support these beams, and the beams support the trusses, and then the walls, and then the roof. So we've got to work out how we're going to hide it. So usually we try to find either a wall that we can hide it in, or some kind of cavity. Just another important note I thought to add. Alright, so obviously in the lower roof, not as much going on. Got the little outside area here, and then the bit down the side that the other wall is not touching, which is this section in here. Alright. This is our roof framing layout for the bottom floor. Not as many walls in the ground here. It's kind of pretty similar to the upper floor. Same things. You've got your bracings, you've got your little wall numbers. But yeah. Alright. What is next? Sorry. Is there anything important that you need to see here now? Not really. All of that will cover in your analysis course. But yeah, lots of little details, I guess, all around these papers here. Feel free to pause the recordings and have a read through it. But unfortunately, I haven't attached the actual panel layouts to this document. And this is, I guess, what comes into their software regarding like the wind. And their software does all the calcs for you, force by area, and then they design the bracing around that, and they get into a kilonewton force, and then they design the bracing to support or to resist these acting forces. Alright, so that is how we put in trusses and a quick overview of the timber framing layouts. So the next video that I do is going to be on our civil works, our cut and fill, and then I'll go through a project overview as well. Thanks guys.